Hi everyone. Today we're going to be looking at the Click PLC EasyPLC PLC mixer programming. Now the machine simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that are used to show different programming techniques. The industrial mixer is one of these machines. When the start button is energized, it will fill up a tank until the lower level sensor is detected. The mixer blades will then turn on until the top sensor is detected. The tank is then drained past the lower sensor and the process repeats 3 cycle times. Once the sequence is complete, the tank is completely drained and ready to start again. Now the Click PLC will be used to program this virtual 3D mixer machine. A drum instruction will be used in the PLC for the sequencing of the actual sequence. When the Click PLC Plus, it will be connected to the mixing machine using Modbus TCP Ethernet for communications. And we will be using the 5 steps for programming development to show how this is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you with video 1. There will be links to the rest of the videos in the series as well. So the first step is to find the actual task that we need to do for EasyPLC mixer. So up on my screen, I have my machine simulator. We're on version 3.10.3, and we'll just start that. And when we start it, we'll scroll down to the actual mixer, which is located right here. If we just click on the actual unit itself, you'll see that we have a description of what actually has to happen within that mixing machine. Again, just as I described, we're actually filling that tank and emptying it 3 different cycles using a fill and a drain. We have some beacon lights and some push buttons. But we also have a demo mode that we can use on our machine simulator to understand what the process actually has to happen. So here you can see that we have our demo mode. It'll give us a little indication here, press green button to start process. So we'll do that. And you can see that we actually are filling up the tank. And you can see a sensor over here, that's the high level sensor. And once it hits that high level, then it will start draining into the tank. And it looks like that's the cycle 1 that we see here at the bottom of the screen. And then it starts filling up again. We can actually fly around here. We can do a first person, so we'll actually bump into it and actually read it from our eye level, or we can use the trip camera and it will actually then start going around and looking at all the different controls. See cycle 3, and then after cycle 3 you can see the mixer blades turning as it fills. It'll stop as it drains, and it's just going to fly around and show you all different angles that we have for this mixer. Tell me to press the green button again, and we can start that again. So in order to program, we have to clearly define the task, right? And that's exactly what we're doing here. So that is our first step. The next step is to actually look at the inputs and outputs of our control. So if we look at, we click the View I/O on our demonstration mode, you will see that the first output's really not used. Then we have our water visible, we have our water empty, our start mixer, and then we have our 3 beacon lights that are located right here on our stack. And we have our input 1 flashing. You'll see that flashing input when we go to start the process. Then on our sensors, our inputs, we have our sensor level high, a low, and then we have our 3 push buttons that we have here. So that is our inputs and outputs. And what we'll do is, the other way we can actually look at the inputs and outputs, we'll exit to the main and from our demonstration mode. And when we do that, what we'll do is then go into our start mode of our mixer. And start mode, we currently do not have the PLC connected. And you can see that right here, no PLC connected. But we can look at and view the I/O, and we can now press each of these buttons to determine exactly what has to happen. So there's my flashing green button. We can fill up some water until the sensor level gets past our low. We can turn it back off again. We can start our mixer, and we can actually zoom over and actually see that mixer spinning. We can stop that. We can test our red light, our yellow light, green light. We can select our buttons here. There's my push button, green, my stop, and then my reset or my jog button. So we can test all these inputs and outputs to make sure we fully understand how that's going to work and what exactly it will do. Then we can also go to our, so once we understand our inputs and outputs, the next part of our sequence is to develop a logical sequence of operation for this EasyPLC mixer. And a flowchart or sequence table is used to fully understand usually what needs to be controlled. It must answer questions like the following: what happens when electrical power or pneumatic air is lost? What happens when input and outputs devices fail? Or do we need redundancy? This step is where you're going to spend a majority of your time understanding everything about the operation, and that will save you time. It will help prevent you from continuously rewriting the PLC program logic. Knowing all these answers up front is vital in the development of your PLC program. So if we take a look at our actual flowchart for this process mixer, you can see that we start off with our stop and our drain open. Then we ask, is the start push button hit? If it is, then we start the light. We turn on the start light. We drain closed, and then we start filling. Then we say, is the lower sensor satisfied? If it is, then we start our mixer. Is the upper sensor satisfied? If it is, then stop filling and drain, or open the drain so that we can start lowering this down. And is the lower sensor not there? And if it is, then you ask, is this the third cycle? If it is the third cycle, then we go back to the start and we stop the drain and open and wait for the push button to start again. If it isn't, then what we do is we keep the start light on, our drain is closed, and we start filling again, going through the cycle until we have 3 times. So that is our flow chart. And just to clearly understand too of what's happening, we basically have 3 different output conditions. We have a fill, and once we get past the low sensor here and we're still filling, we have a fill and mix cycle. Then we have, once we get to the high, then we have a drain cycle, which drains this water down. And then we have, once we get lower past here, then we have a fill again. So that is our 3 different cycles for our sequence of operation. So the next thing we have to do is we're going to develop our Click PLC program. And we'll call up our Click software program. Here we go. And in the Click software program, first of all, we'll take a look at our addresses under our address picker. And we're going to put everything under X101. So you saw in the first one is not used. So that's the first one right here. Then we have our sensor level high, low, start, stop, and then we have our jog or reset button. We can look at our Modbus addresses because that's how we're going to be communicating. And you can see it's 100033, which is the first address. So the second address, X102, would be 34. So that is how we read that. Then we have that is our inputs. We take a look at our outputs. We're going to start at, again, Y101. And Y101, the first address is 8225. There we go. And then we have our visible, and then we have all of our beacon lights and flashing lights, etc. So that is our I/O there. So we'll hit OK. Now we develop our sequence of programming here. And the first thing we'll do is look for our push button start. And when that happens, we start this C1 bit that says cycle start, and we latch that in. And what we're going to do is just we're going to that's what we do. We latch that in. Then the next one is if our sequence is not running, then we have our flashing push button and our red beacon light is on or goes on. If the cycle is running, like you see right now, we have our beacon light green is on. And what we can do is we can actually just put that in stop mode for now. Then what you see is if we have our drum mechanism, and the drum will control the sequence of events for the mixer program. And it's going to fill and empty 3 different times. So how it does that is we have to set up inputs and output conditions for this drum. Now our output conditions, we're going to have 3 different ones. We have 20, 21, and 22. 20 will be the water fill. 21 is our water empty, and 22 is our mixer. And again, they correspond to, there's my drum output, and that will correspond to a physical output that will control our water visible, water empty, and start mixer. And this is conditions on whether the cycle is started or not started. Then we also have our input conditions, or our event conditions for our drum. So here we have our drum water low and not high, so we're in that mixing mode, which is C10. We also have our sensor level low and our sensor level high, so now we're in the drain. Then we have our not sensor low and not sensor low or high. That means that it's at the very bottom or at the start, so then we have our sensor fill. And we can go back to this diagram right here, and you can see mixing and filling, C10, our draining, C11, and our fill again, C12. And if we go back to our event, our drum event, what we have is, there's our drum, and we'll just blow that up, and you can see our sequencing here. So we have 9 steps, we have 3 outputs, 20, 21, and 22, corresponding to what we just saw there for output from our drum. And we have our events, C10, 11, and 12. So when the drum first turns on, we have this output, which is filling. When it gets below the low sensor, which is C10, then what we go to the next step, which is turn on the mixer and the fill. C11 is when we get to the top, then what we want to do is we want to stop the mixing and filling and turn on the drain. When we get C12, which is the lower part, we want to start filling again. So you can see the pattern that it develops on our sequence of events on our drum. And we've also enabled our jog here as well. So if we look at the actual inputs, we have our cycle start. That actually enables the drum. Then we have our reset of our drum. So when we don't have our C1 and we have our push button, it resets our drum. Or when our drum is finished, it will self-reset itself back to the first part. Then we have our cycle start, which is C1, and our jog or our reset button will jog in here and just go to each of those steps. So that is our sequence of operation here. So what we'll do is now what we'll do is go back to our mixer, and let's just restart that machine. And when it restarts it back so that it goes to the initial view that we had. And we will go to the I/O drivers, and we'll look at our Modbus driver. Now, once we have that program, we've now downloaded and we started it up, what we want to do now is to actually test our program. That is our last step of our cycle. So in order to test the program, we must connect it to our Click PLC. So we hit the configure, and on the configure, we will, first of all, we're going to be using the Ethernet or TCP IP address, and this is the IP address of our Click. If we just go back to our software, it's actually under PLC and setup, system configuration, or COM port setting. There we go. And then we can look under port 1, and you can see that under COM port 1 we have this address, 192.168.1.230, which is the address that we're pointing to at that location. So that is all set up for us. And let's go back to our setting up of our Modbus. Next, what we want to do is we want to take a look at our digital inputs. And we saw that it starts at digital inputs, to that is digital outputs to our PLC. We have 10 of them. Now everything's offset by 1. So the first starting address is going to be 8224. Then our digital outputs, or our inputs to our PLC, will start at 32. Again, that offset of 1. And we'll have 10 just to cover all of the different inputs and outputs. And we're not using currently right now any analog in or out. So that is our setting of our Modbus. We'll hit OK. And we'll actually go back to our the simulator here. And when we look at the simulator, you see now there's our inputs and outputs. We can manually move these over to our sensors and our inputs, or we can hit driver and automatically assign them for us. Once we do that, then we can hit exit, start driver and exit. And what you'll notice now is that we are connected to the actual PLC itself. So we're all set to go. Now, right now you notice that we're not actually running and there's no flashing because our PLC is not in run mode yet. So let's go back to our PLC program. There we go. And what we'll do is, let's call up our data view. And on our data view, let's just change our sequence here back to 1. And actually we could probably leave our data view on so that we can actually see that. There we go. And you see right now we're in the stop mode. So let's go and we'll put this into our run mode. There we go. We're in run mode right now. And let's go back to our machine simulator here. There we go. So now we have our red light or our green light flashing. We have our red light here. So that's our starting condition, all waiting for someone to actually hit that push button start. And before we actually do that, let's just take a quick look at the hardware that we actually have here. So here is my Click PLUS PLC, and we are connecting through our Ethernet port right here. And we're actually just using this PLC to connect and program. So our program is actually in this controller and controlling our 3D environment that we see right here. Now what we can do is we can test out our system by starting it. And as it fills up, we'll see our spinning mixer hits the top and then starts coming down again. We can look at our I/O to actually see that operation of our inputs and outputs. Again, as it fills up, you know, spinning, and then it starts draining when it hits the top. Once it gets below the bottom sensor, it will then fill again. And this should be the third time. Once it gets past that bottom sensor, it starts the spinning or the mixing cycle until it hits that top. Once it does all three, then it will stop the process itself. And there we go. So it's exactly what we wanted. So we can experiment with this and we can play around with the actual unit itself. If we go back to our program, our Click program, we can also see the operation of this. We'll just bring that down. And we can actually see the operation of this through our event sequence right here. And what we'll do is move this to one side a little bit. And what I'll do is start it first, and then we can watch the operation. As you see, we fill up. Then we go to the next cycle, which is mixing. Then we'll do the draining. So the Click makes it very nice in order to see multiple things at the same time on our screen. Okay, if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.